Let us discuss spherical waves. Wave functions in spherical symmetry depend only on the radial coordinate. So psi is a function of r and t, where r is square root of x square plus y square plus x. First partial derivative of psi with respect to x is x by r del psi del r, and second partial derivative of psi with respect to x has two terms. First, we have taken the derivative of x by r, keeping del psi del r constant, and in the second term, we have kept x by r constant and taken the derivative of del psi del r. So these are the two factors. Now we add x, y, and z component like this, and then we get del square psi equal to 2 by r del psi del r plus del square psi del r square. Now wave equation becomes 2 by r del psi del r plus del square psi del r square equal to 1 by c square del square psi del t square. Now we can multiply with r. We have got 2 del psi del r plus r del square psi del r square equal to r by c square del square psi del t square, and taking this r inside, so it becomes del square r psi del t square. So that becomes del square phi del t square, because we have redefined r psi as phi. Similarly, these two terms together will give del square phi del r square. I will give this PDF in the description box so that you can see the details of the calculation. Now, it just becomes one-dimensional wave equation in phi of phi. Phi is not psi, but phi is r into psi, but it becomes a one-dimensional wave equation for phi. So phi rt, now we can write f1 r minus t plus f2 r plus t. This is the outgoing wave, because if you keep r minus t constant and increase t, this will increase this outgoing wave, and this is incoming wave, because you keep r plus t constant and increase t, r will reduce. But phi equal to r into psi, so psi becomes f1 r minus t plus f2 r plus t divided by r. This is the difference between plane waves and spherical waves, that we have got a suppression factor 1 by r. So psi rt equal to 1 by r f1 r minus t plus 1 by r f2 r plus t. As r goes to 0, the solution blows up, and for r goes to infinity, when r goes to infinity, the solution vanishes. This behavior is physically significant, because in acoustics it shows how sound waves from a point source diminish at large distances. In electrodynamics, it relates the decay of radiating field from antenna. In astrophysics, it explains how spherical shock waves in supernovas trade out. Here is a pictorial representation. At r equal to 0, there is a singularity, and as r increases, the strength of the wave falls. The applications of spherical waves. In acoustics, sound waves from a point source travel spherically. Electromagnetic waves, radio antennas emit spherical waves. Astrophysics, supernova explosions produce spherical shock waves. Medical imaging, ultrasound waves use spherical propagation for imaging. Earthquake waves propagate spherically through the ground. References: Classic Book of Jackson, Classic Book of Griffiths, and the Classic Book of Born and Wolf. So I suppose you found it interesting, and thank you for watching.